Hi everyone, this PowerPoint is about calculating percentage changes, a very common calculation for National 5 and higher biology. We're going to look at it in relation to the osmosis in potato tissue experiment from the National 5 course. You might have been directed here from one of the e-learning lessons. If you have been directed here from the e-learning lessons, then this success criteria will be familiar with you. We're just focusing on confidently calculating a percentage change. Now, as a bit of a background for those that are joining us that weren't directed here from the e-learning lesson, basically the pupils have done an experiment on potato cylinders, putting them in different concentrations of salt solution. They measured the length of the potato piece before they went in the salt solution, and then they measured it afterwards. I think some people would have left overnight, some people have left it for 20 minutes. And the idea is we want to see do different concentrations of salt or concentrations of water affect the length of the potato. It's all about osmosis, water moving into the potato or moving out of the potato. Now, we're going to calculate percentage changes to compare our different salt solutions. And the reason we do that is because the potatoes might not necessarily have started at all the same length. They might not all have been 6 centimetres or 2 centimetres or whatever. Because if we do a percentage change, then what we're looking at is the difference between the before and after value as a proportion of the before value. And that's why the percentage change is important, because it allows us to compare different situations that might have a different starting value. Now, percentage changes can be positive or negative. Let's get my pen here. They can be positive or negative. So if it's a positive percentage change, it means that it's increased in size or mass or length. If it's a negative percentage change, it means it's decreased, so something's got smaller. Okay. This here is our equation for calculating our percentage change. First, you find the difference between the two numbers, so the starting number and the end number, and then you divide that difference by the original number, so in this case the starting number, and then you times it by 100. But what's really important is you have to find the difference first, okay? So in this scenario, we're going to be doing the start minus the end lengths, dividing it by the start number. That's what we mean by original. And then you do all of this first before you times by 100. Okay? Now remember, brackets. You must do the bracket bits first. So, finding the difference between the start and end, you must get that number first. So maybe there's a change in 2 centimetres. So that would be your difference. Maybe it went from 6 centimetres to 8 centimetres. So the difference is 2. Okay? And then, after you found that, we then find the 2 divided by the original number. Now, what is really important in your calculator, if you're just plugging these numbers in, remember that equal sign before you do the next bit. So you do start minus end, press your equals. Divide it by start, press your equals. Then times it by 100. If you don't do that, and you don't put your brackets in your calculator, which can be quite fiddly, you're not going to get the right answer, because what it will do is it's going to times things by 100 and then start taking things away. Okay? But more on that later, because I'm going to show you some worked examples. Right, so as I said, first find the difference between the two values. You just subtract the smaller number from the larger number. We don't care about positives or negatives yet. We don't care if it's increased or decreased. We just want the difference. You then divide that difference by the starting value, as I said, and then you multiply by 100 to give a percentage. Now, all you have to do is look at the before and after. If it's an increase, if it's a bigger number, if the after number is a bigger number, you add a positive. If the after number is a smaller number, you add a negative. And that's how you work out whether it's an increase or a decrease. It's just common sense. You just look at the two numbers. And that is the only time you start messing about with your positives and negatives. Forget about them throughout the rest of the equation. Here is a nice little slide to summarise it. in case you want to take that note. Now, what is important is if you're struggling with percentage changes, there's actually a problem-solving booklet. Well, you can contact me if you're not part of any teams, but on all the biologies, there will be a problem-solving booklet in the Files tab on Teams, and that will give you some worked out examples and then also give you some to try yourself. Now, let's look at our actual data. Now, we have a results table that looks a little bit like this. You've got your salt solution. For those of you that haven't been looking at it, you've got 3 different salt solutions. They've got the initial length of potato, the final length of potato, and then they calculate the change in length. So we've already started the percentage change equation. We've got the change in length. We're now focusing on calculating our percentage change. So, again, this is the same equation, maybe laid out a bit differently. We're going to do our change in length divided by the initial. And remember, the brackets means you must calculate that first before you times it by 100. So, we're first going to, this is for, when I say first row, it means the first row in the results table. We're first going to do the change in length divided by initial length. And that is our 1.5 divided by our 6. So it's our change divided by the initial length. And that gives us the 0.25 if you plug that into your calculator. And then you times it by 100. So remember, you've pressed your equals, you've got the 0.25 on the screen, and then you times it by 100. Or if you're quite confident with maths, you can just times it by 100 in your head, which will give you 25%. Okay? Now, it's a positive 25% because when we look at our, I'm going to change my colour of pen, when we look at our initial value is 6 and our final length is 7.5, it's increased. So, you put your positive, you put your little plus to show that it's an increase. You will find in this experiment that you will get some negatives, you'll get some decreases. If you're using your own data and you don't get any decreases, or maybe you don't get any positives, something went wrong. You may want to just use my data. But well done for trying with your own data. Once you've done that, the first row, you just keep working it down and you should get all your rows done. Remember that you repeated it 3 times, so you should be doing 9 calculations in total. Once you've got your results table, check with it. Check with my results table, which is at the back of the e-learning PowerPoint that you've got this from, okay? If you struggled with them, like if you're really struggling with calculating percentage changes and you're using your own results, go back and use mine, because at least you can then see me working through it and then you'll be able to know if you've got them right. And again, we've got that problem solving booklet if you're still confused. So hopefully that will help people doing this experiment, their percentage changes, but it might have helped some other people as well. The whole point of this was to confidently calculate percentage change. Feel free to pause this at any moment to maybe jot this down, especially those equations for the percentage changes.